In section 2, we're looking at similar polygons. In similar polygons, we're going to have the same shape but not necessarily the same size. We can think about the angles as being all congruent, but the sides are going to be proportional. Now we're going to use this little symbol here as kind of wavy symbol to talk about similar polygons, and we can also think about the parts matching in the same way that they do with congruent statements. So if I have A, B, C, D similar to G, H, I, J, I would know that A and G are congruent angles. B would match with H, C would match with I, D would match with J. We would also be able to tell which sides are matching. For example, AB and GH would give me my first proportion, and that would correspond to my BC and HI being my next one. Notice that all the ABCDs are on the top, all of the second ones are on the bottom. It's not so much important as about, we could flip all of these over, but what's important is once we choose one to be on top, the other one stays on the bottom. Now, when we put all of those side matches, all those proportions together as one, we call that an extended proportion. Basically, that tells us how all of the sides are related in that figure. A scale factor tells us how we go from one shape to the other. So the scale factor of ABC to XYZ would be looking at the bigger one to the smaller one. So the scale factor ABC compared to XYZ, if we take a side in any of these, for example, they've started with BC over YZ, since those are matching parts, they took their 20 over 8. And so basically any part on that side, if it was 5 on the bigger one, it would become 2 on the smaller one. And so that would be our scale factor of 5 to 2. We usually want to write these as fractions for our purposes. Now if we're asked for the pairs of congruent angles, we should look at our similarity statement because we might be deceived by the actual picture. Because we'll know here that M and S go together, so we know that those are congruent angles. We can see N and R together, P and T together for the same reason. So the extended proportion is going to be based on that. So if I start with MN up here for my first one, think of that as a length, that would compare to the length of SR there. So MN over here would compare to this side over here, SR. Those are both the longest sides. And that'll be equal to our next pair. NP goes with RT. And notice I'm always taking my first one over my second one. The last one on the side to look at would be our MP, and that would be over ST. And that's our extended proportion. If we want to decide if something is similar, then we need to compare the parts. And notice, first of all, looking at our angles, we have a mark here for F and one mark for C, so those are congruent. We have 2 marks for A and 2 marks for D, so those are congruent. B and E, 3 marks, so those are congruent. And we should also compare the ratios of the corresponding sides. So AB is 12. It's between the 2 and 3 marks. So again, between the 2 and the 3 mark would be 15. So they put 12 over 15, simplify it, 4 over 5. BC is between the 3 marks and the 1 mark. Over here between the 3 mark and 1 mark would be 20. So 16 and 20, again, simplifies to 4 over 5. AC over DF are our shortest sides, and the 8 over 10 also reduces to 4 over 5. Since all of these proportions are the same, and all of our angles are matching, then we are similar. We can write it with the correct order in our names, A, B, C, so that our correct parts are matching. And then we can also state the scale factor of 4 to 5. In the next example, notice the angles do match up as we go around. But when we start checking the proportions on here, notice that these are not quite working out the way that we would expect them to. They're taking JK as 12, TU is equal to 1, so 12 over 6 is giving us 2 over 1. The 24 and the 16 are giving us 3 over 2. We could stop right there. We're already getting a pair that doesn't work. And so these polygons are not similar. Now I would actually question whether this is a possible situation because all of the angles are the same. The sides probably should be the same, but they're trying to trick you here and make sure you check it. In this next one we have ABCD similar to EFGD. So notice as we go around here, they are in the same order with the way that they're turned. And so we can look at matching sizes. Y would go with the 5, the X would go with the 7.5, and the 6 would go with the 9. So if we want to find the value of x, we'll look first at x and set up a proportion where we're putting x over its corresponding part in the other figure. We'll set that equal. Since I took the smaller figure first, taking x, I'll take the 6 first, keep that on top, and compare it to the longer figure. Its corresponding part is 9. If I work this out by multiplying both sides by 7.5, I will get a value of x equals 5.